Okay, Unit 4A, Day 4B, we're going to do the same thing as yesterday. So our learning target, I didn't write it in here, but the learning target would be I can graph both sine and cosine functions using degrees and radians with phase shifts. Okay, so we're going to add phase shifts in there. So yesterday we did graphing, and then we did vertical and horizontal stretch and shrink. Now today we're going to add a little bit to that. Now we're going to shift it up, down, left, and right. So a phase shift is really left and right. We'll also do some horizontal shifts also. So yesterday we focused on changing vertically and horizontally. Today we'll focus on translations left to right, which is called phase shifts. Think back, we did the fireproof method, okay? Sorry, my video froze here. There we go. So we did the fireproof method. So I don't know how other teachers have taught it, but I always split it into quadrants like this. So this side over here is the vertical. This side is the horizontal. The top row is going to have to do with shifting. So this top row, same thing over here, shifting. So this is going to be shifting up and down. This is going to be shifting left and right. And then the bottom then has to do with stretching or shrinking. Stretch or shrinking. And now that it's on bottom, okay, so yesterday when it was written in standard form, this B right here, we said it was the opposite of what you think because it's with the B. Well, right now, the way we have written it, it's already the reciprocal effect because now it's in the denominator instead of being in the numerator up with the x. So it is what you think, okay? So these guys, if they're more than one, they're a stretch. If they're less than one, they're a shrink, okay? So they are what you think, whereas up here it's the opposite of what you think. So it's, on the top, opposite of what you think. Down here, it is what you think. If it's a large, 1.1, that's a stretch. If it's 0.9, that's a shrink. Whether it's vertical or horizontal, because it's in fireproof form, it is what you think, and the top is the opposite of what you think. So look at some trig functions with a phase shift. So if you go to Desmos and you graph this, you can, if you want to, you can graph it. Just go to Desmos, graph the following functions. Be sure to change the scale. Remember, you can just go to settings and you can change these values. And so forth. I'm just going to graph it as it is. So if you want to pause real quick, you can pause it and graph it and look at it and say, what just happened? What is putting a +1 on the end do to that? Okay, so right now, as it is, this is in standard form, and we have a +1 on the end. So what I'm going to do, the standard cosine, and what this is, if I do put it in fireproof form, let's do that first. Maybe it says function in fireproof form, so I should do that. So y minus 1 equals cosine x. These are both over 1, so I don't need to write over 1. That means there's no stretching or shrinking. All it is this minus 1 means there's a vertical shift. Okay, there's a vertical shift of 1, the opposite of what you think. So a minus 1 I would think would be down, but it's actually up. Okay, so it's going to be up 1 unit. Now this is, if you want to, this is kind of a translation rule. I think MathExcel may ask you to do this at some point. So all your x values are going to stay the same, but your y values will go up 1 unit. So what was x comma y will become x comma y plus 1. So cosine originally started here and would go through 90, would bottom out at 180, come back to 70, and then at is that 360? Yeah, right there, it's 360. So this was normal cosine. Okay, and we could actually go, let's see, to here. Put the whole thing in there. So that's just normal cosine. But now I need to move everything up 1 unit. Okay, so there's no stretching, no shrinking of any kind. It's just every point you see goes up 1 unit. So this would be my graph. Okay. Now on this one, that baseline we talked about, the midline, is here now. It went up 1 unit too. So you notice amplitude is 1, amplitude is 1. So there's no number out front that changes the amplitude. There's no number with the x that stretched it or shrinked it. That's all it is. It's just a shift up of 1 unit. Okay, so let's turn this guy over. Let's look at a little bit more phase shifts here. So if I'm converting this, I want to write it in fireproof form. So there it is. It already is in fireproof form because this is over 1, this is over 1, everything's the way it needs to be. So the only thing going on here is with the x here. Okay, so there's a minus 90 degrees. When it's with the x like that in the top, it's the opposite of what you think. So this is going to be right 90 degrees, which means I would take this translation, all my x values, add 90 to it, leave the y values alone. So if I think just regular old cosine, cosine starts here, 90. Boy, it's so hard to see these numbers. So here's normal cosine. And I'm going to take all these points, I need to move them right 90 degrees. So right 90 degrees, right 90 degrees. So it looks something like this. I can add this part on to that. Okay, so everything just got moved over 90 degrees. Everything's straight over. Okay, the next guy, I got a couple things going on here. So let's get this into fireproof form first. So get this to the other side. So this would be y plus 2, and then equals cosine x minus 30. That's important, that's in parentheses. So we got two things going on here. Again, these are both over 1, so no stretches or shrinks of any kind vertically or horizontally. But I do have a 2 vertically, and that's the opposite of what you think, so that'd be down 2. And I do have horizontally, so this would be right 30 degrees. Okay, so translation here, my x value is going to be x plus 30, my y value is going to be y minus 2. So that's kind of the idea of every point is going to do this. I'm going to make this translation here. So if I think regular old cosine would start at 1, and again, just kind of drawing that in there to get an idea. So this is, well, I don't have to really draw it, so that's cosine. Now I'm going to take every one of these points down 2 and then right 30. So down 2, right 30. Down 2, right 30. Down 2, right 30. Something like this. Of course, you should probably hit those points. I missed a few there, but that's kind of the general idea there. That's the picture. This one, we keep going that way. Next one. Again, not fireproof form. It's got a plus 3. I got to bring this over. So y minus 3 equals sine x plus pi over 6. Whoops. Like this. So no stretches, no shrinks, vertically or horizontally, but I do need to go 3, and this is going to be 3 up. So up 3, and this is going to be left pi over 6. So now we're back in radians. This was in degrees. These guys were in degrees. This one's in radians. So my translation is I'm going to take every x value minus pi over 6, and then every y value plus 3. Okay. So regular sine, if I do regular old sine, would go through 0. Maybe I'll just make these, I'll just say 1, 2, 3, 4, 5. Here's -1. So regular sine would go up pi. So here's just regular old sine. And now I got to take all those points up 3 and then left pi over 6. Again, pi over 6, think if this was 1, Try to think what would be a third would be about right here, and then half of that. So it's going to be somewhere in here. So it's going to be like left, not quite a whole block, but a little bit less than a whole block. So I'm going to go left and then up 3. So this point's going to go left and then up 3. Left and then up 3. Left and then up 3. Okay, so connect these points. So something like that. Okay. Now, one's the bottom, so just kind of going back and forth here. So what would be in standard form? What's a fireproof form? What's the translation rule? So this guy here, sorry, I'm going to drink. So this guy here, I can see in fireproof, I think it's the easiest way to look at it. So my translation rule on this, I'm going to go through the x's first. I'm going to go left pi over 4. So it'd be x minus pi over 4. And then I'm going to go down 6. So it'd be y minus 6. Something like that. How to get in standard form, I'm just going to get y by itself. So this would be y equals be cosine x plus pi over 4 minus 6. Okay, this guy here, I got a translation. X is not going to be affected, and it is a cosine. So it's just going to be cosine. Now, if I'm going, taking all my y values minus 5, that's down 5 units, I'd have to put a plus 5 with my y to make that become a down 5. And then if I want to put that in standard form, bring the 5 over. So it'll be minus 5. No parentheses. No parentheses needed there. If there was a set of parentheses here, that means something totally different, so we don't want that. Here's in standard form. Bring the 4 over to get it in fireproof form. Okay, and this means my, let's do the x's first. So this would be all my x's plus pi over 6. All my y's minus 4, and that's on the sine, on sine x. So hopefully that helps. Let me know if you have any questions.